Thank you for joining us today. Please save your questions until the end and mute yourself. And for those of you who are first time with us, Serverless Toronto started 7+ years ago as a meeting place for function service developers, but during COVID, we migrated to online format. And over the time, we realized that we could help businesses by working smarter, not by sprinting fast. And we started defining serverless not just as a tech stack, but as pragmatic mindset, a way to focus on the business value. And so this broad definition allowed serverless to explore various IT topics. You can visit youtube.serverlesstoronto.org to check out all the educational events we curated over the last 7 years, and many of them are still highly relevant. And we are constantly cooking something fresh for you. So I hope if you're first time with us, you will join us on July 11. We have Dr. Jana, author of the AI product development book, visit us. This will be less hands-on session, but it is important for future self. Because with AI, you'll be coding less, but spending more time with various product roles. So get prepared for that shift and learn what PMs do and how you plus AI can help businesses. And then later this summer, we hope to have two Neo4j consultants, Tomasz and Oscar, to talk about marrying LLMs and knowledge graphs, because vector similarity is not the same as business relevance. And knowledge graphs provide the relationship like the table of content at the beginning of the book. And the date is not firmed up yet, but we promise you it's going to be valuable, our learnings, when we organize it. And if you have any good ideas or topics to cover or you want to present, mention it in the survey, bit.ly/SLSTO, and we're always looking for good and altruistic topics. And last but not least, I want to thank Manning Publications for supporting us over the years. So they generously donate the title at every meetup. Fill the raffle, the survey at bit.ly/SLSTO to qualify for the Manning Publications raffle. We'll do it at the end of today's session. And for those who don't win, Manning has provided 45% off coupon code for any of their digital products, so you can scan the barcode and enjoy the savings. And let me pass the mic to our returning guest, Dan. Thank you for offering to demystify AI tooling landscape and how Google helps developers, especially Java enterprise developers, navigate into the right direction. So the floor is yours. Please take it away.
Hey, thank you, Daniel. Let me just, I will share my screen. Okay. So I'll share my laptop screen. So if I'm looking to one side, I'm not going anywhere. So let's get started. So what do we want to cover today? From the introduction, I heard many folks are curious. We want to see what's new. We want to learn what's new, but we want to be practical. We want to see how do we build on the knowledge we have accumulated. What do we do today? Decisions we made yesterday brought us to today, but what we decide today will help us or help inform us what we will do tomorrow. So we want to walk through agents, but we want to create a delineation, what agents are, what workflows are, the agentic capabilities, then look into MCP as well as A2A because they work hand in hand. And then we want to see how we build and deploy them in a serverless environment. And we also want to end with pitfalls. Not everything is a fairy tale. We also have to be aware of what can go wrong. I'm Dan Dobren. I'm an enterprise app architect for Google Cloud. I focus on serverless performance optimization in the last couple of years on Gen AI. I come from the app side of the world. I worked before on Spring and in Pivotal VMware, and I'm a contributor to a number of AI frameworks. I want to give you my personal opinion and keep it practical with a number of things which we should keep in mind and which we could use going forward. So yes, Java, you don't need Python to build Gen AI applications. While Python is the preferred language for AI ML, Java is the dominant language of the enterprise. So the investment you made, if you have been building Java applications, you can just add to it and build on the processes, the effort you have built in within your work, whether it's private or whether it's professional. So let's first start by creating a delineation between workflows and agents. So workflows are systems where the LLMs are tools are orchestrated through predefined code paths. Like a state machine, we know the output of one is the input of the next the next one. Whereas an agent will make dynamical decision and it will autonomously direct its own process and tool usage. And it retains control over how it accomplishes the goals which we set out. We set out a goal and we let an LLM make the decision to achieve that goal. Now, in an environment, if we look at things, um, an agent has to perceive the environment as well as the human input which we provide. It works towards the goal we set. It has to act on to accomplish the objectives, and on a constant and constantly has to learn from the experience and the human feedback. Like at its core, it has a decision-making component which would help you process info or evaluate its options, select the next action, and it acts always with autonomy. Now, if we look at the key characteristics of an AI agent, first one would be think. You process info and analyze the environment. Then an agent has to plan the strategies to achieve its goals effectively. Then it has to act and change state of the environment it interacts with. And in the end, it has to reflect, evaluate the outcome of a certain LLM interaction, learn from that environment, and inform its next decision. Now, how did LLMs and agents evolve? Initially, we started maybe, say, a couple of years ago. We had an LLM, we have a prompt, very clear use case, very clearly understandable. But then we needed more information. So we needed access to our enterprise data or private data, which an LLM cannot be trained on. So we added LLM plus retrieval. Then we added tools because by itself, an LLM might not be able to make perform all its actions. So it might need external tools which would help it accomplish that. As we evolved in the last year, primarily we have multiple tools in a reasoning loop, and we're evolving to multi-agent systems which interact with each other. So, what capabilities do we expect from an agent? We start thinking from planning, create and evaluate a multi-step sequence of action. Follow it up with the step-by-step reasoning process. It has to break down a complex task into smaller, manageable tasks in a chain of thought. Then it might require functions to which it has to identify, but also execute to complete such tasks. And it has to reflect each outcome would go through a self-evaluation process for decision making. And last but not least, it has to collaborate within multiple agents, whether it's in its own domain or in remote domains. Now, what type of agents are we aware of? So the first one which comes to mind are LLM-based agents, where we set a goal and we let the LLM make all this decision, how to do reasoning, which tools to use. We give it tools. It has all of these available to make its decisions. But then there are also workflow agents. In workflow agents, we want to combine the autonomy of reaching a goal by an agent with a number of predefined steps. Let's say 3 agents might execute a particular step, and we want to combine them. So the workflow agents support sequential or parallel or conditional or execution in a loop. And the last one would be custom agent, where we combine them all via code in one contiguous application. Now, we talked about workflow agents, so we need to know why do we need these control flows. Sometimes we need a sequential flow. Tasks can be chained together into a sequence of steps. In parallel flows, an agent can decide to break down a goal into multiple steps, discrete steps, which can be run in parallel for performance, lower latency, and efficiency. Then we could have conditional flows. Tasks can be decomposed into discrete steps. And then an LLM would make a decision whether it would use one or the other passes. And each one of these steps could contain other sequential or parallel paths. The last one would be an evaluation loop, because an LLM call generates a response. And these are evaluated and they're fed back into the LLM into a loop. This evaluation could also be a call to another LLM. So, how do we want to explore all of these today? So we have this application. This is built in Java. It's a Spring Boot application, runs on the latest 3.5 of Spring Boot, which was released at Spring I/O 2 weeks ago. And it uses a front end built on the Vaadin Hila framework. So this is all in Java. It runs deployed in Cloud Run. The version of it's not Lambda. This is containerized serverless environment, or it will run in a local environment. I will run the demos locally just so that I can show you logs easier than looking at them in the cloud. So this application would allow us to use the latest model. It uses the latest Gemini Pro, for example, from like 4 days ago. And we can use different components which participate in this agentic ecosystem. We can build slowly one with one or the other and explore them. This, I like to call it like a little postman of the AI world. We can filter by different capitals or continents because all the data is the capital, the world capitals, as downloaded from Wikipedia. Enable safety settings, and you can run it in multiple AI orchestration frameworks. In here, I'm going to show you today Spring AI. You can use also LangChain4j, or you can use directly SDKs. Now, let's think about the first building block. We have a simple LLM with the code. Sure, that's great. But what is the next step? And it has nothing to do with access to the database or so on. It's function call. What is function call? Let's say a user is asking a GenAI app, what's the population of Berlin in 25? So the prompt is sent to the GenAI app, which will send to the LLM the prompt and a list of all the function contracts which are available to it. It's a static operation, so those tools are known. The term is used interactively, functions or tools are known upfront. The LLM might decide, oh, I don't know that, but let me call this get population with the city of Berlin as an argument for the GenAI app will be, okay, fine, I'm going to execute it, and I can use an external API, another service, an MCP server, and get a response. That response is being sent to the LLM, which will use it in its final response to the GenAI application, and that response is being sent to the user. So function calling just execute a number of operations for us, but function calls are not going to have access to our data. Before we get access to our data, let's see how function calls would work. So I have a number of commands I'm going to run, and if we look at the tools which we have available, I have to register them. So I registered a few, and I'm going to say list all the functions I can call in this chat model. Present them nicely grouped by category. So it shows me some currency and exchange rate. It shows me some weather forecast, archives. I'm in the tourist business, and I know about history and geography. Discovery for other tools, and as well as translation. So if we want to see one of the tools in action, I see one, get the currency by country. So if I'm going to travel to Germany, I can call the tool called what is the currency in Germany. So we can see how it invokes one of the tools available to us. But maybe these tools are not always enough. So what would be a next building block? The next building block would be to think about an LLM has a cutoff date. And that cutoff date was, I don't know, maybe sometimes last year. And if we ask a question, we don't have access to any other database, just what the LLM wants, and we don't have other functions, we're asking which athlete won most medals at the Paris Olympics. So because the cutoff date of this model was before July 26th of last year, it does not have the information. Luckily, the model allows us to enable web search. And if we enable web search, it will say, well, from the knowledge I have, I don't have enough information, but let me call the web and get that answer. So it will tell me it took place, and this Chinese swimmer won most overall medals, and there are others who won more gold medals. So we start from a simple LLM, then we can use a number of tools, and we're going to see more complicated ones. And then we can enable also web search. So with function callings and web search out of the way, we also have to think that we need access to our data. LLMs are not trained on your private data. We might work in an organization. We might not have banking or insurance or government information. So we need to have access. So let's say we take some documents. These documents are split into chunks for efficiency because LLMs have a limited context window. Gemini models have million tokens. Others have smaller. There are others who have larger context windows. So we have to chunk them. The way we chunk it, it's very important, and we will evaluate that because it influences us in the enterprise. So we split that into chunks, use a specific model for embeddings, and we create vector embeddings, which are vectors of numbers of that particular chunk. In a multi-dimensional space, we store this information in a database, and when we search for it, we're going to look for the one with the closest vector. So we will store the vector as well as the chunk in a vector database, and that closes our ingestion process. This can be done, of course, out of bound, at night, offline. It's an asynchronous process. On the retrieval side, the user might have a prompt, which it would send to a Gen AI app. And that prompt, the same text embedding model, and we have to use the same for storing as well for using, because otherwise they would give us different data. Always the first best practice you can use. This vector embedding is used to find similar vectors in the database, and we might decide for this app, I retrieve the first 5. And then we want to have context, that context plus the prompt plus the retrieve chunks to pass them to the LLM. So the LLM can now make a better decision, reduce hallucinations, and make an informed decision because it's grounded with information which we make available to it. And that would inform the answer which it would send back to the user. So let's see how RAG would work. That's why I like to have this app. Don't see this as a chat box. It's just as an app for us to try different features out. So if we look at enabling RAG, we might have to pick one of the methods. We might use just passing the document. We can upload here a document if we like, but let's pick one from the database. So I'm picking hierarchical chunking, splitting it into paragraphs, and take a few paragraphs before and after. Is this the best method? We're going to find out, because in an enterprise, it's very important. So it tells us, here's the capital of France, and here's the estimated population at the beginning of 95. So I wanted it to return also sources, because it's very important for me to learn how many items have I retrieved from the database? What is the distance? Well, and also the chunks associated with it. So 0.6, 0.6, okay, maybe not that bad. But if I'm looking at another method, maybe I can get a different response. And if I'm getting a different response, I pick a different chunking method. So now I have a different response. Look at the numbers, 0.4, 0.48. So this seems to be a better chunking method. What do we need to do here? We need to learn to use it for our own data. I'm not saying you should chunk all your data into multiple methods, but a representative set so that it informs you. Well, if I'm not going to go through each one and try them all out. What if I can evaluate this RAG data? So I'm going to say evaluate the RAG data. By this, I'm more or less invalidating anything else. And I'm going to say, please go to the database for this prompt. Give me the top 5. So it gives me the first, which we saw, the second, right? This seems better. The third one, maybe not as good. Is this actually the best we can do to pass this information to the LLM? What if we add now also re-ranking? Re-ranking says, from the data you got, please look how close that retrieved data is to the original prompt. Maybe we just get an exact match. That would be fantastic. So if I run this again and run the evaluation, I want to see what the results are. So re-ranking says, and I set a threshold. I set a threshold of 0.6, just so that it's in between the numbers. So if we see the first one, shortest distance in here, but not the best for re-ranking. This was like 0.6. You see, numbers are fluctuating. So we need to be able to make the best decision here. And we need to be able to make the best decision. You see, for others, doesn't even re-rank it, does not even get us close to that. So it seems for us that hierarchical for this particular data works well. And if we run it, we can determine that. So always go through the data and evaluate it properly. And always look at the source. It's a very nice way for us to see and then to have the data scored by re-ranking, a different way of looking at it. So good. So now we have access. We know that we have access to our data. And when we evaluate that, how do we evaluate it? Here, I'm just evaluating the data which I'm getting from the vector database. But there could be many other evaluation processes. So the team at Vellum had this very nice slide with, and they introduced a term of like test-driven AI development, where you start from planning, then you experiment across models or prompts and workflows, what we just did. Then we evaluate the numbers. Then we make changes in production. We can make changes so that we can say, oh, this seems a better method. This is what I'm going to use in the future. And then you track execution and you observe. This is a constant process which we would always have to follow. Now, usually when a user sends a query to an AI service, the prompt, I get the response, I want to evaluate it. I can use it with an evaluation LLM, or I can use an evaluation framework. There are some, say, deep eval or others. And we can access them with MCP and A2A. They could be polyglot programming. But what is important? We want to find some evaluation metrics: the context relevance, the factual accuracy, the detect hallucinations. We want to compare it with a test data set, which we know is a good test data set, and then we want to generate the evaluation results. Now, we looked at functions, we looked at search, we added RAG to it, and we know that agents need to make their decisions on their own. So how do we go into agentic RAG? What should we look at? We set a goal, and we set a more complex goal. Here's the population. Give me a report. You're a geography and history aficionado, you know that, that's your job. Please look into the population of Berlin, its geographic situation, its historical origin. So when we send that to an agent, in the system message, which will inform how the agent will behave, we're going to say, please identify the topics, create the individual questions. Here I'm using hypothetical question, pick up a different method. Then RAG search in the database, collect the answers for each topic, and then generate a final response. So how would it go about it? So it goes to the LLM. The LLM will create a number of topics. If I'm asking this multiple times, it might be that the LLM might generate a different number of questions. It's a non-deterministic approach. So it will use this function to execute a RAG search, which will look in the database for each of the questions. The individual task could be, what's the population? What are geographic features? When was Berlin founded? Like valid questions to address the goal we set up. With the RAG search, it would pass it to a second agent, which would study the topic, summarize the report for that particular topic. It can use a different LLM. Maybe we want to use a smaller, faster model for just this small summarization effort. And this topic report is sent back with all the reports, all of them being passed back to the LM. The LM can now build a final response for us. So it gives us the final response. Now let's see how this actually works. So we're going to look now. Now we're going to look at LLM-based agents. This is not a workflow agent. We want the LLM to make these these decisions. And let's pick a different system message. So I want to change this system message, and I want to use another one in which I'm just outlining exactly what I just mentioned before. So when I'm looking at things, what did we start with? So we started talking about an agent being autonomous and making its own decisions. So I'm going to add a more complex prompt, including currency and exchange rates, and find also an article in the archive. Add as many things. But what I want is, I want it before it calls any tool, return to me the list of the steps you have identified so that I know how you're going to think. What questions are you going to ask? So it will identify the key topics, formulate specific questions, use the available tools, and compile the information into a report. And then it will generate a number of 6 questions. I asked it for 3 things, but then, it looks at archives, it looks at finding additional data. So how about we try this out? And now we know how it's going to sync. We're going to let this run. Now, I'm running this with Spring AI, and I did not enable parallel function calling. Why? Both Spring AI and LangChain4j support that, but I want to see us to see how logging works. Let me make it maybe a slightly larger. So we can see it invokes this function with this query. It will build a report, and it will send that report to us. And as it goes through each one of them, it will call a number of functions. So we see how it starts streaming the data. Here's the currency. I'm using a free online exchange currency exchange service. I'm looking now in an article in an archive. These are all kind of tools, but I know how it syncs, and I know what it actually runs for me. Very important for us to have an understanding. Now, if we look at this data, we looked at this data, and we had access to tools, and we had access to the database to retrieve vector information. In fact, that vector information could be not just vector database, it could be also a file system or some relational database, whatever database you would choose. I'm using here a database called AlloyDB. It is a Google implementation of Postgres. It's a clean implementation of Postgres, twice as fast than a regular Postgres database. Now, I need more tools and context. So if I'm looking at, I need more tools. Well, we had REST APIs, and every tool we had a different integration. M clients and servers, each one had its own integration. We grew up with that, right? And we learned how to do that. So each tool had its own key. I did not build these two diagrams. They're very nice, and I'll happily quote the author. So with MCP, when MCP was launched by Anthropic last November, the idea was, I need to have a consistent way to access a number of capabilities. And we hear all the time about MCP tools that I can call functions in a standard way. If I know the contract, I can call it, and I'm resolving an M times N to an M plus N problem. But in fact, these capabilities are also resources and prompts, lesser known, but as important to us in an enterprise. So let's think about these capabilities. We have tools which an MCP server would expose tools, which an MCP client would just call. I'm not talking where they are deployed, how they talk to each other. It's just what is available. Then there are resources. Let's say I have a legacy database. I just want to expose it as a resource. Uh, or I want to build prompts. We know that the more we interact and engage with the system, the better we become at writing prompts. But what if we have a number of set prompts which we know would be of high quality? An MCP server could give you a number of prompt templates which it would make available to you. And then there are advanced features. An MCP server does not need to know anything about AI. It could be just an access to a database or a file system or connect to the weather service or my currency exchange. But sometimes it might say, I have this large document. Before sending it back, you as a client, can you please summarize this? So there's this concept of sampling, and you can provide hints to it. So you're saying, take this text, summarize it with the help of an LLM to me. The MCP client, because it was called by an LLM, registered with it, it can do this additional function for it. Rules are for exposing rules to file systems, but sampling a very powerful feature, lesser known. Now, how do we interact with them? An MCP client could be deployed on your host. It's deployed on your host. It could have an MCP server deployed in the same host and access it via standard I/O, or it could have a remote one. While local servers are very popular in all these agentic code-assisted tools, great. They serve a particular use case and they serve it well. For the enterprise, when we build applications, we will have servers which are deployed in a different deployment unit, another Cloud Run service, another maybe Kubernetes service, and that is a remote invocation. I think in the future, these two use cases will both coexist, but on the agentic coding side, we will use local, and on when we build applications, we're going to use HTTP and server-side events. Now, the original MCP version had for remote servers, you had a post, and it has a stateful connection, so you have to get SSE back. The new version, which was released in March, has the ability to run to have streamable HTTP. There are implementations which are coming up at this time in all the major AI orchestration framework. So it's a matter of days until this becomes ubiquitous, and it's going to be great because you can have both stateless and stateful connections. Now, in the lifecycle, how does a client with a server work? So an MCP client will send a request session and a request for a session and the capabilities to a server which it knows where that is. The MCP server will say, hey, here are my server capabilities. And the MCP client would say, send a notification saying, yes, my initialization is complete. But it has to hang on to that connection. It will perform any operations with that server, and in the end, it has to gracefully close the session. We do not want to have resource leaks. Now, if we look at tools, how do we know what tools we have? When we looked at functions earlier, those were functions known to us. But with MCP, we can ask for a list of available tools. So we might not know whether that server has weather services. It might have climate, current temperature, different things. So it might give us a number of tools which are being made available to the LLM. So it would return the tool list, and we can then request a tool execution. To request a tool execution, it's simply like any function call. We know what we call, what parameters we're going to set. Now, when we look at prompts follow the same pattern, but here we can get a list of prompts, and then we can add features like, can you preview this prompt? How should this prompt actually be looking at? I don't want to see only a contract. Help me preview this so that I just get something which I can use. And for resources, in the same way. Now, when we said that this is dynamic access, we also want to be notified when a server changes. If we don't know upfront what a list of tools is, that's great. We want to see what that server can offer to us, but that server can change. That's why that list can change. So when an MCP server changes, it can send a notification to a client and say, hey, here's the server, the number of tools have changed. Please request the updated tools. And if a client chooses to do so, you might not update the tool list with every single update on a server, but it depends how you want to implement it. Maybe you want to do it at startup of an instance or on a timely basis. or you can proceed and do that all the time. Now, you can do that as well, not just for tools, also for prompts, and also for um, resources. Now, for sampling, when we send a request to an MCP server, the MCP server will say, hey, it creates a message and say, sampling, please sample. I don't know why they use necessarily the term sample. Could be like need additional help or need additional content. It will send this request and it could provide some hints. Maybe say, hey, LLM, use Gemini Pro or Gemini Flash, or please filter out any message larger than a response than 1 meg. And an MCP client can call an LLM, maybe a summarization, which we're going to try out, return that response, make it available to the MCP server. The MCP server might not know anything about LLMs. It might just be a server. So before we see how we collaborate across domains, let's see how we collaborate now within our domains. So let's reset this and look into MCP. Why do we call this just tested via tools? So that we are aware that that this functions independently of whether we have RAG or not. So when we looked at all the functions which I can call in the chat model, I can see a number of them. Some could be regular tools, which I just registered. Some could be MCP, some could be A2A, and I see a number of them. But I want to be more precise. So I'm going to travel to, for example, Germany, and I want to see now, get more capabilities about Germany. So I'm going to look at the weather forecast. Well, there's this weather forecast, and it says get weather forecast for a specific capital. That's great. So I'm going to say list all the capabilities of the weather forecast for Berlin. So I'm not getting just tools, I'm getting also prompts and also a number of tools to help me execute a prompt or list prompt or preview them. So if I see the list of capabilities, why should I not just try and get the MCP tools available, just the MCP tools? So I'm going to see, what would it tell me? Well, there's a get climate by capital. There's a get the temperature. So I want to see what the temperature is. And I can provide it by geolocation or by the capital name. I use a geolocation service. So if I have specific locations, it can find what city that is. But I also want to see, I see this. So let's execute this. Why don't we execute this? We see um, climate. So why am I not going to ask what is the climate in Berlin? Okay. So what is the climate in Berlin? I want to see what it would execute. It would send a request. I can see what is happening under the hood. This request took its own sweet time until it accessed the server and says, oh, I cannot provide this. The request timed out. Well, that happens with services which we do not control. So why don't we just clear this content, try it out? Okay. So now it's fine. So it lists the prompts. No, that's not what we want to say. We want to say what is the climate in Berlin. It could time out again. Depends what service. These are services which this is Open Meteo, and there might be delays there. This is possible. So okay. So you do not want to reply to me. So then that's fine. let's say, let's use something else. What is the current temperature in Berlin? So Open Meteo can tell me that, and it says here's the temperature measured at 22:45 local time, and it's 14 degrees. So now I call this MCP server, and I see this up and running. The sampling server failed the sampling example, and because it uses a different one. Now we have prompts. So we said we want to see these prompts. If we have these prompts, I see all these prompts, so weather forecast and different things. So I want to say, please preview the prompt weather comparison. I see this. What does it mean? A location, second location, and a time frame. So I'm saying, what's the weather comparison between Berlin and Paris in the current month? So it will tell me, here is the prompt preview, and here it gives me a prompt in which it will tell me exactly how I should be running. Now, if I'm asking this, as we're in Canada, if I'm asking it about the climate in Ottawa and for the winter, I don't think I need an LLM to know how cold that's going to be. And it will give me a nice prompt. So we can use now LLMs for our function for getting prompts as well. Now, all of these operations happen within our own domain. So I know the domain. I have regular tools. I have MCP domains. I can secure them easily. MCP by default does not have security enabled. It does not allow us to put a no-off token. But within our network, we can secure that. Well, we can easily do that. But many times I might need information from another domain. Oh, I see maybe something nice in Paris, and maybe I want tickets. Or I get a document. I got asked for an article about Berlin, but now I want that to be translated into German, so that maybe I want to read that in a different language. So what should we use here? So Google introduced at Google Next introduced agent to agent for agent collaboration. It is uh, a separate protocol to MCP, and they're complementary. This is my own interpretation of my internal domain or an external domain, but I think it might be accurate because these domains are governed separately. Now, A2A supports agent discovery. It is secure by default. It has all tokens. It focuses on the collaboration between agents, not just tools or um, resources. It's built on existing standards. You can run short or long running tasks, and it's modality agnostic text, video, audio. Now, if we think about them, MCP connects agents to tools, APIs, and prompts with resources. And A2A is dynamic, multimodal between different agents, and they don't share any memory because they are consider them in two domains. We could, let's say a bank might have a customer domain, a payment domain, a product domain, for example. This is an open standard and it's driven by community. Now, if we think about it, how we said it facilitates discovery. It has an agent card. An agent card is just a description in the form of a JSON file of all its features, its capabilities, its skills, how you secure it. So this agent JSON will always has to be, as per protocol, be made available at the public endpoint at /.wellknown/agent JSON for discovery. And it will tell us the authentication scheme. I'm using text here, and it will define also skills like what does it do, read tags, examples. This is to access maps, like plan my route or what's the commute. from here to there. And it can work together with MCP. How should we discover them? Maybe we have an MCP server which discovers all the different agents and makes them available to an MCP client as a resource. A very nice thing. And let's see. Let's try this out. But before that, if we compare them, MCP would standardize element tool communication inside the domain, whereas A2A will go across domains. But they complement each other because they all work for interoperability. You can use them together. They're both evolving. And we should expect major changes, major additions by the end of the year. If we are to look at drawbacks, MCP does not have dedicated auth and no specified discovery, whereas A2A has the agent JSON at a well-known location and auth for authorization. So let's clear our application again. And if we look at A2A, I want to say discover any agents available to this chat. This is a very generic question. But when I'm saying discover an agent, it looks through the tools and says, oh, there is an AI translation bot here. Oh, very nice. So what do I want to know? I want to know, what is that agent card? What information does it have? So it will get me the agent card. It will tell me it's a professional AI translator. This uses a Google Translation natural language processing service. And it gives me different examples in different languages. So what do I want to try out? So I want to say, well, find an article about Berlin in the archive. Before sending it to me, I can either, okay. So you see here, I'm asking it to do two operations. So I'm going to ask it again in a slightly different way. So I'm going to say, please go and answer this. So it finds the archive file. It finds the archive file and with MCP, but it failed in the translation. This can happen. We're going to give it one more try. But you can see I can go and retrieve this. It should call the second one. It does not want to do that. Very nice. Now, we looked at MCP, we looked at agents. So when we think about building agentic workflows, we want to think about a framework which should help us bring the world of autonomous agents with a deterministic approach of workflows. So how should we go about this? If we think about it at the lowest level, we can run, we can do it ourselves. We have REST APIs to models. We can build everything. But we can add a lower level LLM framework. So the lower level are like the SDKs on top of like Vertex, Gemini models, MCP. These are independent libraries. They facilitate for developers because they're available in the ID. They facilitate our work. They ease up our work and make our life a lot easier. This is probably the lowest level at which we want to jump in as developers. But they're the closest to the truth, so to say, but they're also more verbose. So there are low-level orchestration frameworks like Spring AI or LangChain4j, which would abstract a number of models. So we would call a model, say, create a chat model, set the tools, and call that, regardless of the models which we use behind the scenes. So for us as developers, we can work with multiple models and in a similar. The next level is when we want to combine them all into an agent framework. So the agent development kit has been launched now in Java at Google I/O like 2 weeks ago. It is available in Python for some time, but the version in Java is available, and we can use it. The last level is if we build these no-code platforms where we literally don't know anything about programming and we just want to use it. Now, how should we think about agents based for ADK? We have the LLM-based agents, which we work with, and they're responsible for reasoning and tools and transfer. And then we have the workflow agents. At this time, they support sequential and parallel and loop agents, and the Java version will add evaluation. So the last one is custom logic, where we write code in which might say call this agent with a set of goals, then iterate through the responses and maybe translate them in 3 languages, and maybe in the end call another LLM to summarize everything. I'm just making up a flow. So in here we can write our own. Now these agents allow us to build also hierarchies of child agents, and each one could have different tools. Now, as implementation, it's open source. It's code first. We use it at Google already internally. It supports the Gemini models and any LLM via the Lite LLM interface. You can deploy them anywhere, your own machine, in the cloud, wherever you like. You can containerize them. And in Google, every application, we recommend that you just containerize it. Once you containerize it, then you have deployment choice, whether you run it in a containerized serverless environment, or you want to run it as cloud functions, or in Kubernetes. The deployment unit is a standard OCI container. Or you can run it on Google Agent Engine, which is a specialized service for running agents. Now, it supports a hierarchy of agents, flexible orchestration. You can do state management for short and long term, and it supports the box support for tool calling and A2A for multi-agent scenarios. So you can build complex solutions here. Now, I'd like to go through the next thing. I'm mindful of time. I'd like to show you two things, and then if we have time, I'll show an ADK demo. When we think about building a platform, a GenAI platform, it's easy to just, we write a few lines of code. I have this app, we can try different things out. Is that a production-ready GenAI platform? Not really, because we have to address a number of building blocks, and we should keep them in mind. We always start simple. I have a user, I have an LM, I send a prompt, I get a response. But that might not be enough. And we explored how we added RAG and agents and query rewriting. And we got data from vector databases or those files from a file archive. And those provide additional context. The next thing is input and output guardrails. Guardrails are very important in the LLM world. We would be nice to have one also for Zoom calls if something like that would exist. Because when we send a request, we don't want PII data to leak by any chance into an LLM. We also don't want inappropriate questions to be sent, but also on the output, we don't want inappropriate, maybe child inappropriate or hate messages to be sent out. So guardrails are a concern from us from day one. And then we use LLMs also for scoring. We use that for re-ranking. We use the scoring model. Or we can route to the services which we want, the other agents which we want to, and also for evaluation. But what comes even after that, like, okay, this is running, but performance is a problem, because performance comes also with a cost. If we cache the same responses, yes, the great large token users are fantastic. If I want to summarize Shakespeare's work or ask 10 questions, they're a 5.5 meg file. I don't want to send it 10 times. So I can cache I can cache, and now we have implicit caching supported by Google models. the request, or we can do semantic caching of responses. If we always get the population of Paris is like 2.5 million, maybe that answer is asked by a lot of tourists. Maybe we can cache that response. But overarching over those is observability. And that should have been put as the first one, but it looks better because it's pervasive across every step. When we build distributed systems fail. Some get restarted. Services get restarted. Factor 10 is factor 10 disposability in the 12 factors, or now 15 factors. Well, one of them. So observability very important, and how we have the ability to trace the request. The last thing as advanced features, do we want to allow for write actions? Do we trust our agent to send an email on our behalf or writing to a database? That comes after we set all of them before that, and we have the level of trust built here. Now, when we deploy, we have multiple choices. Once we containerize our agent, we can deploy them, maybe an agent and sub-agent to the same deployment unit, let's say a modulet, or we can deploy them as individual services. Whatever we decide, we can deploy them all, and here we pick serverless in Cloud Run. Why? If we had services which have to start fast, services which have to have high throughput, low startup latency, the serverless environment will bring us that. Well, if we build native Java images, which started in Cloud Run and what we explored in the last session back in November when I was invited here, we had services starting in like 500-600 milliseconds. Now we want to have the same characteristics as we build our GenAI applications. So we can have the root agent, which we use today, starting in 700 or 800 milliseconds as a native Java image. We have to be aware that the way we configure our secrets, how we configure our API keys are the same as secrets, the same value for that. They should all be treated as secrets and as environment with environment variables. We can choose different models. We can decide to run also smaller models in Cloud Run at this time. So I have a service, I have a Gemma 3 model, which runs with Ollama, with an Ollama interface, and an NVIDIA L4 GPU in Cloud Run. So rest assured that the work you did to understand how to containerize app and to deploy them safely and securely, that's the same work continues. It's not a wasted investment. It's even more because you would want to have, and there will be an explosion of more usage in the AI space. You might build services which need quick scalability or need access. You see, when we deployed this service, it generated 6 questions. If I enable parallel, it might be 6 requests. It might have to scale up quickly. It might not execute sequentially. It very much depends what my application needs to do. But when we build things, when we started from simple functions, search, RAG, agents, MCP and A2A, internal and external, all of these help us build that. And these are practical things which we learn, we test, we evaluate. We have to do that and constantly. But there are always pitfalls. And what are these pitfalls? Using GenAI when you actually don't need GenAI. So let's be reminded that GenAI adoption starts from business needs, not technological aspects. We might need quick summarization, quick translation. GenAI is great for that, absolutely. But if we just need access to a service to retrieve from something from a database, we don't need that. So always use it when you need it. Conflating a bad product user experience with a bad AI. No, starting with the Gen AI app is easy. Even this app failed once in the UI. Bringing a good production is the hard part. Should I take this app and just share it with everybody? Not until I put additional work in. And starting with a complex solution rather than an evolutionary app architecture. So, for example, using an agent framework when direct API calls in a workflow address the use case. If you have, for example, add a picture taken on vacation, maybe validate that the image is not inappropriate, maybe enhance the image with some filters, write it into a cloud storage bucket. That's a clear workspace. You can use services. You don't need an agent framework. You will need AI services to do that, but you can use it. Now, being also optimistic that an initial demo success translates to production greatness should always be looked at with care, because reliability, safety, security are first class concerns for a production app from day one. In the past, we needed to be sure that we don't have SQL injection or retrieve the wrong data. But here, we're adding additional concerns. Now, the more these services evolve, we're going to rely on them for AI as a judge and as a huge substitute for human evaluation due to the sheer amount of volume. But we always have to correlate human judgment with AI judgment because it's our responsibility. If responses diverge, investigate the AI judge. Again, our responsibility. The last one is failing to continuously evaluate and gather feedback. You have to evaluate model responses and they react to changes. Use this feedback to evolve. When you change a text embedding model, it seems a very small thing. You have to redo the embeddings. Why? Because they bring new features. But we always have to keep this consistency and this parity. I'm going to end this time. Thank you. I'll answer any questions you might have. And if we get time, I'll show you also an ADK demo. But for the time being, please feel free and ask any questions you would like.
Bravo. Thank you so much.
Okay.
You over-delivered. If you want to mention ADK, that would be good, and then we can stay longer for questions, like if you plan for it.
Yeah. Okay. So if we look at ADK, so let me start this. I'm going to start this separately. So with ADK, I did not integrate it into the app because it's net new. The Java uh, version came out on Google I/O on May 20th. But you can write a number of agents and you can execute. But the team built a Spring Boot application which they make available out of the box. And the only requirement is to point it to the folder where your agents are and to implement the root agent called base agent and with a certain variable. That's all. And you can run different agents. What is interesting here? If I'm asking what is the time in Toronto now, it will tell me what function it executes. But the nice thing is, this is a multi-tool agent. It will give me current time and weather. It will show me step by step. Here is the agent, the first step. The second one, I get a response with the time. Here is the function response. Here's the response. I can now trace them all. And in the end, here is the response. Oh, it's 7:13 p.m. In the evening. So it gives me a very nice thing to a way to ascertain what it does. But the more interesting thing would be here if I'm going to just say write something nice. So this is an agent which should take a crack at writing a little story. And then we want to evaluate that response, iterate over it, and issue a final response. This might take a few seconds until it comes up with a story. But all right, so it writes whatever something generic, and it will soon. This is not yet done. So it will tell me now. Here are the steps. It shows me that it called the initial writer agent, and then I expect a refinement loop with a critic agent and then a refiner. What I'm looking at the request, I'm looking at the response, but I'm also seeing that I have a failure in a timeout. So you won't be able to see all the different steps. But if I'm taking a science agent, I'm going to say, give me a brief idea what the Formula One race in Montreal is about. So there's a Formula One race for all of you racing fans this weekend in Montreal. We're going for Father's Day with my children, and it will tell us quickly what the agent does. It will give us the contents, each part as it works, and I can also run it as with token streaming. So as a framework, too bad they had one timeout. You would see multiple steps because there I know I want to write this relational story, then I want to evaluate in a loop. If I just send it to an LLM, first just generated the story, but I might want different things. So here's an agent framework, comes in very handy. If I need it, I should use it. If I don't need it, I should just use the LLM agent. Should you combine them? Yes, as you see. So questions?
Thank you. So Harshita has hand raised.
Yeah, we'll do that one, and I'll also turn back on the chat, and we'll just keep an eye on it there.
Yes. Harshita, go ahead.
Wait a second, I got to allow him
Uh-huh.
unmuting. Just 1 second. Okay. Yep.
Thank you. So when I was looking at a couple of things actually triggered this question. One, sometimes the agent did not want to answer the question you were asking it. And generally the number of tools you had in the interface that you were showing us. What is there a cost to running all of this and setting the stuff up?
No. So here's the thing. When I started building this app and the tools, I just wanted to explore a number of things. I have this privilege of working with customers all over the globe. Also, my focus is primarily in the US and in Canada. And you get different questions and you want to show different features out. So I figured out how about I started building a number of things. Then I started adding tools. So adding another tool is literally no effort. I just write a separate tool and all I have to do is just add it to the configuration. There is no cost of building anything. Now, when I call the LLMs, there is a cost of invoking an LLM. There are different LLMs with different capabilities, different throughputs, and also different cost points. Gemini models are very cost effective, and as you can see, the responses are quite fast. So the idea is, no, it's not complicated. We want to show different things, but it's built as an evolutionary architecture. I added A2A just in the last few days. I'm going to wire ADK inside. So imagine like this app could be an app which you build in an organization and it evolves, but it should be composable. It should evolve, and we should set up things from the beginning. Guardrails, I enable guardrails here. I can test for guardrails. So the effort is not complicated. They're small parts, and they all come neatly together. The entire code base is not very large.
Thank you so much. No, that's very insightful.
Who wants to go next?
So, yeah, actually, I mean, hey, this is Manu. So it's very nice presentation and demo. We get something. So actually, right, Google is developing ADK, right? So it is code without auto code something. So I mean, if you're seeing here MCP, serverless, and client server model, is any tool we can add up here? I mean, with the ADK, with the MCP, multi-agent, those things. I mean, is there anything you in future are going to take presentation or something?
So MCP and ADK are both open source. You can contribute to them. You can and the A2A protocol. These are open source. You can just contribute to them. And there are many organizations. While MCP was started by Anthropic, A2A was started by Google. But the MCP implementation I use today, the Java library which I use today, is literally agnostic of any framework, and it was donated by the Spring team. The Spring AI team actually donated. Now, for each one of them, whether they are just orchestration frameworks like Spring Avalanche A4J or an agent development kit like ADK, they are built to run on any cloud in any kind of integration. Will there be evolutions in here? Yes. Like, for example, with ADK, you can have access to Gemini models or access via light LLM. But what if you want to use your something very different, which something like a Spring AI or LangChain for J would facilitate? So enabling Spring AI in ADK by just registering tools, registering MCP tools, and benefiting from the features of those frameworks are great things to add. But these are available in Python and Java. Other languages are being added. They're open source, and you can build up to your imagination, so to say.
Yeah, one more. I mean, continue to that question. So actually, nowadays all are talking about Agentic AI and those things, right? So tools and Agentic AI frameworks, like for example, like QA and Microsoft EAC. What is that? Yeah, I forgot that. Sorry.
Autogen.
Yeah, Autogen. Yeah, yeah, EAC. So like Google, I mean, what is that current enhanced Agentic AI tool framework we have in the Google?
So ADK was started by the Google team.
Yeah, I know that. Any further any advanced? I mean, only ADK, only that Agentic AI framework Google is developed as of any.
Well, there's ADK for this particular purpose. Will there be in the future new features or new frameworks? This space is evolving. Imagine that in November there was no MCP. In January there were already frameworks implemented. It by now there are like hundreds and thousands of servers available. You can access your Google Docs, your GitHub, your Jira. A whole number of things. So this space evolves very quickly. And I think our focus should always be on understanding the main concept, the things which we need to pay attention to, what we should explore in more depth, and let tooling evolve. Where we can, we should contribute. And this would evolve on a very fast pace.
Sure. Thank you so much. Yeah.
Sure.
Okay, next hand raised. Go ahead.
Yeah, it's Ghazala. Hi, Dan. Thank you for the presentation. So my question is, when I am working on some personal projects, and when I have a root agents with some sub agents, seeing that the root agent struggles to orchestrate if, for example, a task requires first subagent 1 to execute, and the output of that goes to subagent 2, and then that goes to subagent 3. Most of the times the loop kind of breaks in the middle, and I get outputs from subagent 1, and then as a user I have to keep prompting the root agents to get to the final result that I want. So I wanted to ask if this is also something that you have encountered, and what are your advice to deal with this? Is this possibly a prompting issue, or maybe
it's not necessarily a prompting issue? Now, let's also think that the AI is an engagement type of tool. The more we engage with it, the better we become at prompting. So we can get better information. We like to write something, a quick line, give me this. For the purpose of a demo, we cannot write nice elaborate prompts. But a prompt can introduce a request for more or less work. One of the things, the first thing which you would have to check in your applications is if I would assume you're calling an agent to a sub-agent via asynchronous or asynchronous, but HTTP. Look at the frameworks we use and set the timeout. Sometimes I set timeouts at small amounts, like maybe 10 seconds or 30 seconds, but that might not necessarily be enough. So look at the timeouts which you have to do. The second thing is, these are synchronous, but a good part of the work we do is asynchronous, is event-driven. I did not even get into event-driven architectures and how we can use now A2A between two agents working within two different environments in a totally separate and time agnostic manner. Let's say I have an approval as I don't know, an insurance agent, and I need a higher approval limit. I'm going to put a message on maybe on a queue or a topic, and another agent can pick that up. It might do it within a minute, but it might also need human intervention and do it on maybe next day. So you have to consider also event-driven architectures would help you address some of these areas. But indirect calls like agent to agent, look the first thing at the timeouts you have. Look at the frameworks you have, enable them at debug level, and then you can observe most likely whether this is a result of that. Now, again, depends what we ask of it. When we summarize, I wrote a blog like a year ago of how to summarize documents. If we have this million token context window and we say, please summarize this, it will take some time. It might take 15 seconds, 20 seconds. But if we chunk the document and process things in parallel, the results might be much faster and sometimes even more accurate. So we always have to look at this particular execution.
Okay, got it. Thank you so much.
Sure.
Then there is a question in the chat. So you covered that, but people are not getting it open sourceness. It says, will there be any possibilities, future plans to support agent engine to deploy in other cloud providers like Azure, AWS?
I do not have an answer to this. I'm not privy to that information. Agent Engine runs in GCP. If you want to build agents using ADK and use them in a hybrid cloud, and it doesn't have to be another cloud provider. It could be also something you run on-prem. Right? Many organizations run these hybrid environments. With ADK, you can do that and connect agents. So Agent Engine is one versus ADK as a framework to enable, to facilitate that is a different thing. One is a programming contract, the other one service.
So use ADK. That's the answer in your.
Yes, if you want to do that.
Yeah. And then there was a question here about learning everything. So the links will be provided with the recording. So start from here. And do you have any other tips then?
Yes, from this. Sure. If anybody wants to reach out, you can reach out over Twitter or LinkedIn. Happy to answer questions. Not a problem. There's a question, a point of view of understanding agentic AI. Enable, integrate. Well, that is going to be the premise of A2A. Let's think about this. We might build. I showed you two services here. I can get the agent card of my translation service, even if that's all timed out. It doesn't matter. It connects to it. So they might be two domains which are within my org, but they could be totally different. Let's say I might buy tickets to some concert, and that might be a different service. That A2A service, I might find it same as I find it in any I can find it in an agent marketplace, and as long as I have the proper token to connect to it, you can just use that. Will this be common as the agentic world evolves? Yes, there will be services which would allow us to integrate different things which we are interested in. like to watch, for example, a tennis game, but I might not know, for example, much about the 2 players or 4 players being on the court. And I might have a service, and that might be a service, I don't know, at some tennis site. And I can discover it if I can have access to it, and I'm in the middle of a chat. I might commenting on the game while I'm watching. I might be able to do that. So the challenges of working across organizational boundaries, that if you consider that like from the premise of microservices when they came out maybe like 10 years ago, at that time, the idea was that microservices will help democratize access to tools and services and resources. How that materializes, that very much depends on each organization. I built a microservice framework 9 years ago with other colleagues at that time when microservices were not popular. Is that in use in production? Yes. But how did that change? Well, that respective organization has access from many services to this set of microservices. That's going to be the same as in the agent world. Things which we have learned in the past are not going to change. We just bring new things. We bring easier integrations. We bring maybe more streamlined integration, but we also bring more responsibilities on us. How do we evaluate? We need to constantly evaluate. When we ran tests, we had a CRUD service, create a person, update a person's name, delete a person, list person, right? The results are always the same. Whereas in the LLM world, we might change models. We might, prompt might be similar, but not the same. How do we evaluate the response? What data do we have? So we add things to what we know, but there will also be things which we have also to think more about how we build programmatically. If we just use a ready-made tool and all these like fantastic AI tools, like great, you use Notebook LM, ingest all the talks from Google I/O, and then just say, tell me in 10 bullet points what each one of these talks gave. That's fantastic, but that's not programming. Here we're just like developers trying to build things and expose a different aspect to building agentic apps.
Thank you. Any other questions? Like we are a little bit over. I can stay, but I don't know about you.
I'm fine.
Any other questions before we do Raffle? Maybe, okay, so because nobody's asking. So I'm curious about this MCP toolbox for databases. I think it's underrated, like it's a bigger thing that people are aware of. Everybody's writing the MCP for their database. Can you mention it?
In 1 second, I lock my screen.
Yeah.
I have a hotkey. MCP for
Toolbox for
databases.
databases. Yeah, that's a Google open source project. I don't know if you used it.
It is an open source project which Google has, and the idea is actually great. There are several types of databases which you have, and you might have Postgres for example, in Cloud SQL, but also in AlloyDB. So I might want to have an MCP server which should give me direct access to that data. Let me see. I have a link saved. Yeah. So the idea is that I have, for example, with ADK, support automatically with MCP. What if I have now access to this MCP toolbox for databases? I can connect to Alloy and BigQuery and Bigtable and Cloud SQL and Neo4j, just Google database, but also database available in the marketplace. So it is a very nice way. It's like a single point of contact for how you would access that. I have a link. I can post it here in here. Yeah. And there's I think there's a demo link to it.
Thank you.
Interesting for you to try things. Out. For developers, there is this credit. It's $300 for Cloud AI and ML services, and you just register and use it, and you can use it for quite a lot of apps to build. You don't need to run analysis of Shakespeare's words, but you might want to have a number of documents which you learn how to chunk them, like how to try different methods out, how to have agents call each other. So it very much depends, but very handy, and use it because it's available.
Thank you. Any other questions, or I'll go to Raffle?
Oh, putting MCP in front of a database. Well, it very much now depends on, like we said, MCP has no dedicated security mechanism. Now, if I expose a database as a resource, and that service, let's say I'm in my own network, and I have my root agent, which is now exposed, and I can secure that. If all the services are within my network, I can secure that service with service accounts and provide restrict access to it. The same if this is my own database and I control the same as I would make it available to the app, let's say for a direct connection, I can secure that behind my. If we're talking about giving this as an access to a service outside of the domain, that all the security aspects would play for that, and then we would not be using MCP. We could be using A2A.
Am I sharing the screen, right screen?
Yeah, we can see the wheel.
So let me last minute check. So nobody else did the survey. Thank you everyone for doing this. Any other questions, or are we gonna? I feel bad. We are almost 7:30, but this was so good. Then you're always welcome to come back and surprise us with something new. It's always a pleasure. And you broke my Zoom. Like I got warning, over 100 limit reached upgrade. So thank you. So spinning. Good luck. And I have to apologize for everybody who's watching this through YouTube, because normally 1/3 of people show up, and I did not expect like 400 people registering. Vin, are you with us? I here paste your email address in the chat.
Yes, I'm here.
Congrats. So paste your email address here, the one you use for manning publications, and I'll introduce you with the nice folks from Manning, and they're going to give you a free ebook or course, just no print products. Thank you. I hope to see you, everyone, again soon. Then thank you for spreading the love for cloud, AI, Google. So it's
Thank you for inviting me.
pleasure. So come again, and then be safe, and see you July 11th. Lunch and learn. It's not evening, it's lunch and learn. I guess it's from Europe.
Thank you, everyone.
Thank you.
Thanks, Dan.
Bye.